Here's a pretty typical initial value problem. What they're asking us for is the original function, little f of x, if what they provide to us is the second derivative function. So knowing that derivatives and integrals are inverses of each other, what we can do is integrate this guy 2 times to get back to the original function. There's one little hiccup though. Every time we integrate, we get a plus c, as we know. So what we're going to also have to do is use these initial conditions that are provided to figure out the plus c's as we go along our way to getting back to the original function. All right. So here we go. If you want little f of x, the first thing we have to do is go from the second derivative just back to the first derivative. We have to go one step at a time. So let's try that to begin with. So f prime of x will be the integral of this function 6x plus cosine of 2x. Alright, so the integral of 6x would be 3x squared, and the integral of cosine 2x, I'm going to kind of speed through this kind of quickly. It would be 1/2 sine of 2x. Now, in case you didn't quite catch where I got that from, I'm not going to take time out of this video to do it, but this uses something called U substitution. So if you haven't looked at those videos yet, you might want to pause the videos and watch one of those first. But it's when you have composition, like not cosine of x, but cosine of 2x. And then we have a plus c. And also, confident that this really is the correct antiderivative, because if you took his derivative, and you can check me on this, you can pause the video and try it, this guy's derivative would be 6x plus cosine 2x. So that's the derivative, but the issue, as we stated earlier, is this plus c. I have no idea what the plus c is. So this is where we're going to bring in one of our initial conditions, namely the one for f prime right here. F prime of 0 really needs to be 2. So this means when we plug in a 0 for x, we should get out 2 for the derivative. So I'm going to take the derivative out, plug in 2, and on the right hand side I'll have 3 times 0 squared is 0, sine of 0 is 0, 0 times 1/2 is 0, so we get 0 plus c. And so, hey, this is actually a pretty easy one. C is 2. So what we're going to do is take this c value, come up here and replace this capital C with 2. Now, just because I can, I'm actually just going to go ahead and do that right here. You'll probably need to actually just write out a second line, but I'll just go ahead and do that right now. So this used to be plus C, now it's plus 2. So this is your correct derivative that on the one hand satisfies the second derivative, being 6x plus cosine 2x, as well as when you plug in 0, you get 2. All right, so that's one step back. Completed, done, finished. All right, now we're going to go from the first derivative back to the original. All right, and its initial condition is f of 0 needs to be 5. Okay, so I think I might just erase this right here now that we're done finding the c value. So we'll just start right here. All right, so little f of x will be the integral of this guy, 3x squared plus 1/2 sine of 2x plus 2 dx. So this guy's antiderivative would be f of x equals x cubed. All right, now this middle term here, it's going to need that u substitution again. So if you haven't watched those videos, depending on what order you're watching these videos, you need to go watch those first to see how to integrate this middle term here. But I'll just go ahead and tell you, and you can understand the idea behind the problem without knowing specifically how to do this integral, but it would be a good idea to review this. This guy's integral would be minus 1/4 cosine of 2x, and then plus 2x from the integral of 2 plus capital C. So this more or less is your answer. This is, almost finished. The only issue now is this plus C thing that we have to deal with again. This is not a specific function. This is a family of functions. But I can determine the specific plus C based off of this initial condition here, f of 0 needing to be 5. All right, so what we can do is take this function and say that when x is 0, okay, so we have 0 minus 1/4 times cosine of 0 is 1, plus 2 times 0 is 0, plus capital C. We're saying that this needs to be the number 5. This needs to be 5. So 5 equals C minus 1/4. C minus 1/4. So C, let's see, after some algebra would be 21/4. And I did go through that algebra kind of quickly. You can check me on that. But I'm pretty sure this is what the C is. So to finish this up, we're going to take this C out and replace it with 21/4. And that should be our final answer here. So I'll just do that real quickly. Pardon my laziness here. I'm just going to erase some of this stuff and just jot it in here, being that we're almost done. So I'll take that C out and replace it with the 21/4. Now, what does this answer mean in closing? Well, this answer, this function little f, satisfies all the conditions that were stipulated at the beginning of the problem. Its second derivative should be what they requested. F prime at 0, should be, should be 2. And when we plug in 0 into this function, we should get 5. And so we check all three of those. They all three work. You're welcome to do it on your paper, but that's how we know that this is the specific function that satisfies all the conditions above.